Good evening, everyone, or good afternoon, those who live in the Western states. And it's nice to meet you via Zoom today. So I'm going to briefly talk about the microplastics in our environment. And Tamila, thank you for your wonderful introduction about me. So I don't have to introduce myself again. So I'm going to move to the next slide. Okay. Right. So today I will just briefly share some of my microplastics research today. So basically, I'm going to talk about some background of the studies and then also review of the sampling and analytical method. And also, I will share some of my ongoing study progress. The first study is characterizing airborne microplastics in Philadelphia. So acronym is CAMP. And the second study is about microplastic exposure assessment in laundry and dry cleaning industries in Philadelphia. Our acronym is a MELD study. And after sharing some of my ongoing progress of these two studies, I tried to propose some research recommendations and then also conclusions of my studies as well. Okay. So because Tamila already introduced the background, so I'm not going to talk about in detail, but I'm an environmental and occupational health scientist, and I'm actually wearing two hats. One is the exposure assessment that Tamila already explained about what I did. And then the second part is about the environmental epidemiology. I'm very interested in how chemical exposures or non-chemical exposures affect the human health at individual levels or the population level. So, all right, so today's talk is about microplastics. So I'm not going to talk about in detail about what are the microplastics, assuming hopefully everybody has some sense of what microplastics are. So, but I just want to reiterate whenever we are talking about microplastics, actually there are two types of the microplastics. So first one is about primary microplastics. As many of us know that these microplastics are intentionally fabricated in industrial settings, such as like microbeads used in personal care products, or industrial abrasives or the pharmaceuticals, or even the paint materials that we purchased from the Home Depots or the Lowe's. Those paint sometimes include the microplastics as well. So in this case, we call these microplastics primary microplastics, and usually their physical size is less than 1 millimeters. Unlike the overall definition of a microplastic size, less than 5 millimeters. And another source of the microplastics that we say is the secondary microplastics. These secondary microplastics are not intentionally manufactured in our environment, but once the consumers use those microplastics materials, such as like the empty the plastic bottles, or maybe even some kind of the food containers that after we consume the food, and we discard those the waste haphazardly, and then actually the plastic bags or the wasted plastic materials are actually just like the deposit in any environment, as we know. So it's about maybe in the ocean or the stream or even soil and many other different places. And then when they are exposed to the air or maybe the water, and that they actually degrade when the time goes by throughout the weathering process. And these are the waste of the plastics, including packaging materials, and even sometimes the textiles, and then also tire wear. And also some of the plastics actually degraded. They are actually the deposit in the road dust, and then they kind of resuspended from the dust into the air. So in many cases, when we are talking about microplastics, and nowadays we focus on these secondary microplastics, we know very well that especially these microplastics had serious the pollution issues in the oceans and the rivers or the stream waters or even the storm waters and so on. However, the microplastic can exist in air, water, and then soil, and as well as the food. And because of that, this microplastics ubiquitously exist in any environment. They can actually circulate through the entire ecosystems, or maybe in our Earth. So actually, the microplastics are present everywhere. Okay. So when we are doing the microplastic researches, so there are several challenges we have to uh, bear in mind. First of all, we want to know whether microplastics present or not. That means we have to collect microplastics in environment accurately. And then also we have to measure microplastics also accurately. However, there are several challenges are known. For example, like the first challenge is about the sizes. Because microplastics are very small size, it is very difficult to identify or maybe detect those microplastics in the environment. So there are the difficulties to detect them in air, water, or soil, even food as well. And then also the quantification is very difficult. And another thing is that actually nowadays there are so many different ways of the collecting microplastics and different ways of the analyze the microplastics. The one of the advantage of the using different method is this kind of such a flexibility to collect and identify microplastics. But on the other hand, that means we still do not have the standardized method to collect microplastics, and the standardized, we also lack of the standardized method to analyze microplastics. So this is the issues about the sampling method. Everybody's different, and then also identification techniques also different. So it is unlike the other the study or the result that are related to biological studies or maybe chemical studies. So especially the microplastics wide, sometimes one of the big challenges is very difficult to compare the result from one study to another study. So I think that's kind of one of the big challenges. And but thankfully, especially for the water sample collection and analytical method wise, American Standard Technology method recently standardized how to collect water samples in the streams or lake, and then how we analyze microplastic using what type of analytical method. So the standardization of the sample collection and analytical method are on the way, but there are still many other things that we need to tackle with. And even if, let's say that we have the standardized sampling method and identification techniques, but there are still other challenges in the real world because that the issue is related to sample contaminations. The sample contamination can occur anytime from collections or when we analyze the microplastic in the labs. So because the microplastics are ubiquitously present in any environment. So because of these challenges, sometimes we cannot directly compare the results from study by study. And sometimes, though, unfortunately, those reported values from the studies, sometimes they overestimate or underestimate the microplastics in any environmental media. So, and now I'm just kind of briefly talk about the analytical methods, how we are going to identify and quantify the microplastics. There are several new analytical methods are being added, but today I'm just only focusing on three types of the analytical method. So microscopy method has been widely used uh, over decades, and especially the optical microscopy is a low-cost analytical method. However, this optical microscopy is sometimes inaccurate because we use the optical microscopy and the magnification is about maybe 400 times. So that means that we can detect and then identify count microplastic in the collected sampling media, but that's only the small portion of the areas. And then the smaller size of the microplastic, such as like maybe less than 100 micrometer, is very difficult to identify using our visual inspection. So to kind of complement these difficulties, we can use the electron microscopy, but this is way, way expensive. So in general, this is very difficult to have the electron microscopy. And nowadays, many scientific the research groups and papers publish the microplastic identification and quantification using spectroscopy method. In this case, this spectroscopy method is a little bit more advanced than optical microscopy. This spectroscopy method, they usually classified into two groups. The first one is a Fourier transform infrared, or we call it FTIR spectroscopy. And then another, the method is a Raman spectroscopy. So the FTIR was kind of used as like kind of more intermediate analysis, and it's a better detection method than optical microscopy. So it's like maybe up to like the 5 years ago, and then like maybe 2 or 3 years ago. So the FTIR was very popular tool to detect microplastics. And but however, the FTIR can has some limitation. They cannot detect microplastics like let's say the size less than 20 micrometer or maybe the 50 micrometer. So then people are thinking about, oh, so because those are small size, like 20 micrometers or less, toxicologically very relevant to human health when we consume these microplastics. So then the people are nowadays very interested in identifying and quantifying the microplastics using Raman spectroscopy because Raman spectroscopy can detect microplastics size as small as like maybe like 2 or 5 micrometers, which is like toxicologically relevant once we consume these microplastic inside the human body. So in my ongoing study, so we use this Raman spectroscopy analysis method, and we also use the FTIR as a complementary method. We also use the optical microscopy. But today, I'm going to just show some ongoing the progress of our study result using the Raman spectroscopy. And another the methodology about microplastics is mass spectrometry. This is kind of more relatively new compared to these two microscopy and spectroscopy method. This is especially the pyrolysis GCMS is emerging methodologies that many investigators are trying to use as well nowadays. Okay, so I think this like kind of like to talk too much about this some challenges about the sampling and the analytical method. But as an environmental health scientist, I'm very interested in how we consume these microplastics and via what kind of the exposure route. So the first of all, we can just think about the ingestion of the microplastics by consuming contaminated food or maybe drinking waters containing microplastics. And I know that there are a lot of studies have conducted and then interest in ingestion of the microplastics. But my kind of motivation for my study is about more inhalation of microplastics. When microplastics exist in the air, when we breathe air, it's actually that we are also consuming microplastics when we breathing air. So my study is more interesting and focusing on the inhalation. And of course, the other studies also the focused on the microplastics exposures via dermal contact, such as like using maybe personal care product or maybe some other the route of the exposures. And of course, the microplastic exposure also should be age specific, especially the older adult, because when those older adult live for several decades in this world, is actually they accumulate a lot of the microplastics over their lifetime. Okay, so now I'm going to talk about how I studied the inhalation of exposure to microplastics. So the motivation is actually started about 4 years ago. I read a seminar paper published by the Brenny. They actually collected air dust in several western states, including the Colorado, I think the New Mexico, and the many other several the states. They placed a glass cup or maybe stainless the steel cup outside of the urban areas or maybe the rural areas, and then put those cups for several weeks or several months. And then the air dust is actually deposited on inside of the cups, and they analyze the microplastics actually depositing in the cups. And what they found after their analysis, and they kind of estimate where those that detected microplastics across different states potentially came from. So they simulated and then developed a model, and then they kind of estimate that the microplastics suspended in the air, about the 84% actually came from road dust or maybe the braking emission. So that means that when the vehicles are actually stop and go, or maybe the moving along the roadway, the tire wears is actually overrated. And then the rubber materials is also part of the synthetic polymers that actually emitted to the air, and then so actually those are the contain the microplastics, and surprisingly they estimated the microplastic in the air mostly coming from the road and the tire wears. And of course, they found that about 10% of the microplastics in the air is actually came from the sea spray. The microplastics found in the oceans, kind of they suspended in the air during the tide or maybe the wind, and then actually they transferred to the urban areas. So that's what found. And about the microplastic you deposit in the soil is about less than 5%, and so on. So at that time, the many investigators focused on the water pollution issue. So then I was kind of interested in, if their modeling is true, so can we detect microplastic in the air, especially like the Philadelphia, because the Philadelphia is an urbanized city and also close to Atlantic Sea. So I want to know whether that is their estimation is true or not. And the way that I focus on the microplastic in the air is that also there are several other regions. First of all, in the air, when the microplastic suspended in the air, microplastic size usually greater than 100 micrometer. I mean, because we know the microplastic is their size up to 5 millimeter. But when microplastic size is greater 100 micrometer, they do not move to another location. They easily just fall out to the ground. However, the microplastic size is actually smaller than the 10 micrometer. Those are very small, tiny size. So then we cannot see. But when these microplastic are inhaled into human bodies, and then they actually account for approximately more than 90% of the full size of the microplastics. And then several review studies at the time suggested that the inhalation of the airborne microplastics uh, was estimated 2 to 3 times orders of magnitude greater than ingestion of the microplastics through food consumption. So, but it was also speculation from those studies, but I also wanted to know whether that is true or not. And then, as I also mentioned earlier, that these inhalable microplastics, usually size smaller than 10 micrometers, they can be easily deposited in our lower airways, such as like the alveoli or inside the lung. And then they are very highly relevant to toxicological effects, such as like oxidative stress or maybe inflammation of the lung. And also the another thing that we did not know at the time was exposure assessment of the nano-sized plastics, such as like size less than 1 micrometer, was not fully evaluated at the time. So these are the things that my research motivation when I started this study about 3 years ago. So now I just want to briefly introduce about my first study, the characterizing airborne microplastics in Philadelphia. Of course, we have many different aims of this study. However, I just want to share one of the aims of this study today. So the camp study aim that I'm going to present is to first, we wanted to collect micro and the nanoplastics across different locations in Philadelphia. And then once we successfully collect micro and the nanoplastics, and we want to count total number of the microplastics in these locations. And then we know that the microplastics actually are composed of the many different types of the polymers, such as like the polyethylene or polypropylene and so on. So we want to also identify specific chemical, the composition of the microplastics and the nanoplastics in the air. Excuse me. And then after the analysis, we also want to compare the microplastic concentrations by two different seasons. We want to compare the microplastics and the nanoplastics between summer and winter, because environmental condition is definitely different to degrade the microplastic between winter and the summer. So we wanted to know whether seasonal effect is one of the determinant of the airborne microplastics. So as you see this slide on the left side, these are the map of the Philadelphia. And this about the, let's see, I'm looking at the map. So as you see in this scale, especially on the bottom side, is about the distance from west end to the east end is probably like less than 6 miles. And this is how the Philadelphia look like. And each dot are our proposed sampling locations to collect airborne microplastics across 2 years. And for example, like the different locations were selected by based on the land type used. So for example, as you see on the left side of the slide, especially the location A, This is kind of more residential areas and surrounded by the park and then also trees. So we potentially thought this A location, probably airborne microplastic would be very low because there's no nearby the traffic sources or the roadways. And on the other hand, the location B, as you see in the east side of Philadelphia, is very adjacent to freeway I-95, and it's very heavy traffic roadways, and also a lot of the traffic's going on every day. So we thought the probably this B location would have high the airborne the microplastics because of the road dust and the vehicle emissions. And the C location is kind of more mixed of the commercial and then the residential areas. And unlike the B location, there is no major freeways. However, that they have also a kind of large arterial road and also surrounded by commercial the buildings and also residential homes as well. So to do that, so how we did that? I mean, we were not able to collect samples on the same day across these 48 different locations because I'm not a kind of such a huge research group. So actually our team went to several of these locations, like maybe 3 or 4 locations on the same day to collect samples at the same time. And then they move to the next locations and so on. So on your right side, we actually use the kind of mobile sampling, the strategies. As you see here, we brought out our sampling devices and they collect the samples during the daytime when the people are actually doing the daily activities more actively across the day. So to analyze these airborne microplastics, there are many different ways that we can do. But as I mentioned earlier, so that we are focusing on the Raman spectroscopy. The reason is that, as you see in this graph, Raman spectroscopy can analyze the microplastic size less than 10 micrometer or less. And the Raman spectrometry can identify the microplastics based on their shape and also polymer type, such as like polypropylene, polyethylene, and also number of the microplastic that we can count, which is kind of more consistent with the previous research methodologies. Okay, so that was just a brief overview of our campus study. So now I'm switching to indoor air microplastic exposures methodologies. And so that is the MELD study. So the one of the aims of our MELD study was to examine the effects of the workplace factors, such as like the building characteristics and then the work load, how these the factors affect inhalation of let's say, the total or volatile organic compound and the carbon dioxide. But mostly we are very interested in the microplastics in the air, especially in their workplaces. So the background of this study, those who are familiar with in the Philadelphia, they probably well know, but those who are not familiar with the Philadelphia situation, and especially in the Philadelphia, that we have a lot of the commercial shops, including the cleaners, is actually located on the first floor level. And then from the second level, there are residential the areas. So basically, those people who live in this building is actually kind of maybe the consuming or the inhale any of the air pollutant probably generated from cleaners. Just for disclaimer, this cleaner does not generate any pollution. Just one of the typical examples that I show you here. So there's no this cleaner is not related to our study. And but as we know, it's like maybe you remember like kind of maybe 1 decade or maybe 2 decades ago, many cleaners used to have a dry cleaning machine inside their shops. So then they actually process or cleaning the garments inside their shops. And those who remember that those dry cleaning machines actually use the perchlor, the ethylene we call perc. That is one of the considered human carcinogens. It's early the 21st century. So then US EPA is actually the regulated law that actually phasing out these perc machines. And then actually all the dry cleaning machines located within residential buildings, as you see on the right side of this slide, they have to remove all of the dry cleaning machines by 2020. And the city of Philadelphia also followed that regulations. And then now, city of Philadelphia, all core residential dry cleaning operations, actually, they completely do not use the perk uh, in their facilities. So what nowadays dry cleaners do is when they receive the garment from the customers, they actually packed and then send those the garments to a centralized dry cleaning factory per se, and then they just clean them, and then it's just bring those garments, and then the cleaners actually give back those cleaned the garments to the customers. So nowadays the dry cleaners are instead of doing the perk or the dry cleaning the practices, they are routinely doing so many other things like such as washing or maybe drying or ironing, and then also folding or maybe tailoring. But nowadays, our the clothing is almost like at least 70% of our clothing materials made of the synthetic materials. And because of that, when they are, especially the dry cleaning workers, they handle this garment every day, maybe more than hundreds of them. So actually, this clothing shedding microplastics. So I was kind of interested in whether they were inhaling microplastics in a small confined place when they are working at least 10 hours per day or maybe 12 hours per day. So as you see this figure, and these are our sampling locations, we visited all these dry cleaners in Philadelphia and then suburban of the areas. And actually we were able to recruit 34 dry cleaners in our study. Okay. So, and once the dry cleaners they agreed to participate in our study, so what we did is like kind of we obtained informed consent form on first day, and then we deployed our air sampling devices. As you see on the right, the pictures, we collected airborne samples for 2 consecutive working days. Of course, our sampling were conducted from the beginning of their workdays and at the end of the workdays for 2 days. And then on the third days, we revisited each individual dry cleaners and then take down these air samplers and then administer questionnaires about their demographic information, shop information, and also other work practices. And we conducted this study, the 2024, starting from February to November, because we were not able to visit 34 shops one at a time. So we visit like 3 or 4 shops for each month. Okay? And the July was kind of very slow month. So then we ended up had no the samplings in these dry cleaner shops. Okay. So this is just a brief overview of the study method in these MELD studies. And we administer survey in English and the Korean because in this location, many of the dry cleaning shops are owned by the Korean populations. And then not only for that, we also obtained their demographics, workplace characteristics, And then also we ask them about the knowledge and attitudes of the microplastics, and then also the what are their the workplace practices. And then after we gathered this survey data and then also microplastic information, and then we analyzed the data. And this is just the kind of the basic information of our study population. This population is very relatively old. It's kind of the older adult. Their average age was over 64 years old. And we have like about half of the female and the half of the male participate in our study. But in each shop, we only recruit one person because we don't want to have the kind of bias or misclassification of each individual shop's characteristics. And in our study participant, as you see here, is about above 70% for highly educated, and they actually their shop size about over 13 square footage, and then the number of workers are less than 3 people per shops. So usually the dry cleaning shop, they like kind of the husband and wife usually work together. So then considering that instead of those two owners, less than one additional employees is actually work for each individual shop. Sometimes it's family business, so their sons or daughters actually work together. So it's kind of more family business. Okay. And in the shops, we found that among 34 the shops, 32 shops responded that they deal with the static fabrics every day, and followed by natural fabrics and then heavy linen. And also when we ask them about their job task, many, over 90% answered that they actually treated garment repair and alteration, followed by folding and packing. And also 22 said that they involved in the dry cleaning. But this dry cleaning does not mean that they do the dry cleaning inside their shop. So they, as I mentioned earlier, they just pack the clothing and they send it to the centralized location far away from their shops. And then actually they received those clean the clothing and then they give the customers. Okay. And we also asked them about their whether they aware the microplastics in the air. And surprisingly, less than half of them knew what microplastics are. And so we kind of divided them the two groups. So first one is a yes means that they heard about microplastics, and then no means they have not heard about microplastics. And then also we tested their basic knowledge about the microplastics, and then we converted their knowledge score from 0 to 100. 100 is the maximum score they can get. And then as we anticipated, those who heard about the microplastic, they knew very well about the microplastics. However, those who have not heard about microplastics, their knowledge score was very low. And so then we also asked them whether they use any type of the personal protective equipment, such as like the wearing the mask or maybe having another kind of the gowns when they are work. And but surprisingly, only less than 30% answered that, only less than 40% answered that they wear any type of the personal protective equipment while they are working. And so we were kind of puzzled. And then so we kind of tried to see whether is there any association between microplastic awareness and then personal protective equipment use. And surprisingly, we thought that those who are aware the microplastic wear personal protective equipment a lot. However, our result did not show those trends. So as you see here, the odds ratio is less than 1. So that means kind of more contrary result. Those who have not aware the microplastic are likely to wear more personal protective equipment. So we was kind of perplexed. And but as you see here, this result is not actually statistically significant. Maybe this is related to because of our small sample size, or maybe there are some other another reason that we couldn't capture in our survey studies. Okay, so now I want to share some of the ongoing the study result about the microplastic data. Okay, so the as of right now, this is ongoing progress, and among 48 locations, we just completed microplastic analysis at 4 locations for campus studies. And among 34 shops, we just completed our analysis in MELD studies with the 3 shops. But as you see here, for the outdoor air, for the campus study, we found that the total number of the microplastics in the air is approximately 92 microplastic particles per cubic meter. However, in our MELD studies, the airborne microplastics concentration is approximately 225 microplastics per cubic meter. So in a nutshell, it's about maybe the indoor air concentration is approximately 2 times greater than the outdoor air. Of course, this location is not the general home environment, so we anticipate microplastics in indoor at this workplace is a little bit higher than outside. Okay, so what about this level? So we pull up the existing studies that reported number of the microplastics found in the air. So as you see this graph, and please note that the y-axis is a log scale, and the x-axis are individual studies that we identified in the world. And as you see here, the lowest, the microplastics in the air is about 0.01 the particles per cubic meters. Up to some studies reported that the airborne microplastics are greater than 10,000 particles per cubic meter. So as I mentioned earlier, so our campus study, the range is around 100, so maybe around these areas. And our the MELD study result is about 220, so it's around here. So it's kind of comparing these the studies published so far. So the microplastic concentration in the air is kind of the high trend. But please remember, so as I mentioned earlier, so we just have only a small portion of the data. So this the analysis is not the complete. Okay, so then what about the microplastics polymer type? As you see here on the left side, this is the result of our campus studies, and we found that especially the polyethylene, polypropylene, polystyrene, and the polyethylene tetride consist of more than 90%. And of course, in the MELD study, in the indoor air, is that these 4 polymer types are major component. However, we found that there is a little bit of the differences of the proportion of this specific microplastics. So for example, like the indoor, the air, especially the dry cleaning shops, we found that polypropylene concentration is relatively smaller compared to our campus study. However, we found more the proportion of the polystyrene and the polyethylene tetride in the indoor samples compared to outdoor. So in our study summaries, so we found microplastics in both indoor and then outdoor air in Philadelphia. and the indoor air is about at least 2 times greater than outdoor air. And the profiles and the proportion of the microplastics are different between indoor and outdoor. And one of the another thing that we found that among dry cleaning and the laundry workers, we found that their awareness and the knowledge about microplastics do not always translate into protective behavior. So based on our ongoing finding, here are some of my research recommendation for the future studies. I think we have to develop more rigorous methodologies to detect nanoplastics and also comprehensive exposure quantification, including some cumulative exposures, not only indoor and the water, soil, and the food samples. And then also another important thing is, even though we have focused on the microplastic itself, I think the teasing out the combined effects is very important because plastic materials not only contain microplastics and also contain other additives and derivatives such as like plasticizers or the PFAS or maybe phthalates or heavy metals. Those are also highly the toxic component to human health. And I think there are not many studies have done so far. So I think especially the community comparison is also interesting to see, and whether the urban and the rural communities, the level of the microplastic would be similar or the different. And it is obvious that microplastic presence in any environment. So if that's so, we want to identify some highly polluted areas. And if that's so, we also have to do some kind of intervention studies to lower the microplastic exposures. And so then how to address the microplastic in the community level? I think this like kind of we can do is there has been some success so far right now, such as like phasing out microbeads and the improve waste management program and also promote eco-friendly packaging. I think nowadays, especially the many grocery stores, do not use the plastic bags. And also we need to educate the public to raise awareness and encourage their personal actions. And also most important thing is like we have to involve with the communities. And so what are our next steps? Yeah, so we are going to continue to analyze our samples. So we will complete our lab analysis for remaining samples. And then, of course, we will do more in-depth data analysis to tease out whether those microplastics comes from the road or the sea or some other sources. And also, we are going to report back the result to the workers. And then also we'll disseminate the results. And also we hope to establish new collaboration with the community-based organization, especially to move past plastic and other organizations. And finally, we confirm that microplastics are everywhere and exposure begins from birth to the end of our life. And nowadays, the analytical method is rapidly evolving. So there's a way that actually we kind of compare the recent studies with the previous studies. This is still challenging. I think the most important thing is the collaborations among policymakers and scientists and the community leaders. I think that's very important. And I would like to thank my lab members and students and then technicians. And this presentation is partly supported by NIHS and the CDC. And thank you for your attention. And I am concluding my presentation.
Thank you so much, Dr. Han. We have some questions from our audience. Are you ready for them?
Yes.
Okay. So one question from Jimmy Farnan asks, did you measure the cellulosic, or other natural fibers? And from a toxicity perspective, do you think plastic morphology, um, whoops, oh, I lost, hold on one second. Morphology is more important driver compared to a polymer type? Well,
So yeah, the first answer, we have not measured cellulose or the natural fiber. I think that that's the kind of one of our limitation in our study as well, because we know that especially these even though it's a natural fiber, the fiber is also the one of the kind of the risk factor for the adverse respiratory effects. But unfortunately, we have not the measured fibers. And the second, the question about the morphology, I agree that the morphology probably is more important than just the polymer type, because the polymer type is just, I consider the polymer type is just a kind of surrogate of the what kind of the different chemicals in those the exposures. So I think the morphology or maybe some other the maybe the detailed chemical ingredient is more prone to the toxicological standpoint.
great, thanks. And then another person asked, what is the material of the PPE masks? On their plastic, right? And so is there exposure from the microplastics and the chemicals within the masks that are supposed to
Uh-huh.
protect them from the microplastics?
Yes, yeah. So I think that those are the most of them when they wear the mask, they use a kind of surgical mask. I believe that those are kind of more polyethylene or the polypropylene. So probably it is likely they may inhale some of those microplastic while they are wearing those the kind of let's say surgical mask. But some of them also reported that they wear N95 mask, and then also some of them also asked them, answered them, they wear the cotton type of the mask as well. Yeah.
Mhm. Now, but don't aren't all of them made up of plastic? All three
Yes.
types?
Yeah.
Okay. And so, is there any studies that you know of how much microplastics someone's breathing in and out?
There was a study published in China, but I cannot recall at this moment so how much they consume.
Okay.
But they found some portion of the microplastics were inhaled while they were using it. But I think probably their major conclusion is like probably protective. The benefit would be outweighed than inhaling microplastics from those surgical masks or the other PPE.
Yeah, yeah, that makes sense. Another question is what are some effective filtering solutions for residential use?
So the effective filtering solution, so I assume uh, that the our maybe the HVAC system or air conditioning system, probably, I think. So if that's so, I think probably we could use like those kind of MERV type the filters, probably good enough to filter out the microplastic if they are exist. And then also those the MERV, let's say 11 type of the filter is also good for filtering out, let's say, pollens or the other airborne particulate matter. So it's like kind of maybe I can say the two for one or maybe many for one.
Yes, yeah. So and if people a lot of people don't have a central air and so they can just get standalone HEPA filters
Mhm.
or air purifiers and that can be important. something that I tell everyone for Move Past Plastic, we're doing tabling events this year, and we decided to focus on fast fashion and microplastics from fashion. And I always ask people, if you're inhaling and you're digesting microplastics, how can you decrease those? And in particular, with inhalation. And I haven't had one person give me the right answer for the simplest things that they can do. So just for fun, in the chat, um, if you guys wouldn't mind, what is some simple things that you could do to minimize your inhalation exposures in your home? I'm curious to see what everyone comes up with in the chat. Great. You're doing much better than the people that come by the tabling events. Yes, simply just vacuum and dust with a damp cloth and a damp mop. And that will keep a lot of your microplastics from in the air. Um, and then I have a question for you, Dr. Han. What do you tell somebody when, I inform them that their most beloved things, their fuzzy blankets and their stuffed animals are made up of these microplastics that are readily releasing from those items? Do you have suggestions for them other than finding natural alternatives? Should they throw them away? Should they keep enjoying them?
Yeah, I think it's like kind of let's say actually this is a very hard question, but the let's say I think it's probably it depends on the age of your I mean age of that person's age of the persons like per se, and then also considering the health conditions, like usually even if I say it's like yes or not, but it's like the people knows what is the best for him or her, I think. So it's like if even if there was a fuzzy the stuff and it's like somehow bothering like a mucus or the maybe respiratory tracts, so should throw away. But if not, probably enjoy those nice features. Uh, but I think the in a nutshell, it's like kind of if those people who are not actually exposed to very large amount, probably it is okay to keep it for a short time, but maybe in the long run, maybe it's like a phasing out, probably it's like the best way for healthy for ourselves and also animals as well, I think.
Yeah.
Because animals cannot talk.
Yeah.
Yeah.
I kind of tell people that if you have a newborn baby, go all natural, young children, and then,
Mhm.
don't throw their favorite blankie away,
Yeah.
that they're attached to or their stuffed animal.
Yeah.
But just, just minimize dust, clean around it, and then moving forward, try to
Yes.
buy natural
Yeah.
fibered items. Does anybody else have questions? And you're welcome to raise your hand and ask now that the presentation's over. Okay, Jane, go ahead. Unmute yourself.
Hi, Dr. Han. I was wondering if you can go back to the slide where you compare your results to other studies. And I was
Yeah.
wondering, is that showing that Philadelphia has a more higher microplastic problem than other regions? Or do you know what? I guess I was a little confused about what that is, like
Sure.
a green and blue line
Yeah.
and a black and that one. Yeah.
Yeah. So so the for the blue line is about the microplastics we detected so far in the Philadelphia outdoor air from our campus study. And the green line is the microplastics levels we found in these dry cleaning and laundry shops. It seems higher at this moment because it's like kind of more the like right side of the right side of this figure. But I just want to be very careful or cautious because we have only the small number of the sample size so far. So at this moment, it seems very high in Philadelphia. So I don't know whether this is going to be sustained or not. But as of right now, what I can tell is that our detected level is kind of more high end, but this does not actually I mean, the final result from our study so far. So
Okay.
whether I answer your question.
Where is reference 20 and where is reference 29?
Yeah, so these are
40.
reference
Oh,
to
what?
29 on is the kind of more middle, I think the Middle East countries so far.
Oh,
And
wow.
probably East, I think the China and so on. Yeah. And of course, in the lower end is kind of more European countries, and then in the middle is kind of mixed so far. Yeah. But once again, this is only the preliminary data, so I mean, this is not a complete data yet. Yeah.
Well, we're 5 minutes over, so I just want to thank everyone so much for coming and taking your busy evening to learn a little bit more about this topic and this research from Dr. Han. And I want to thank him for giving this presentation. And I'm excited for him to come out next week to do some sampling. And any last minute questions that anyone wants to ask, you will be getting a recording via email, and also you can find it on Move Past Plastic. And I hope you guys did notice in the chat, we have a pollution report form for putting in a report of where synthetic playing surfaces, poured in place playgrounds, rubber mulches. We're collecting that. And then Beyond Plastic has a document to help your dry cleaners move to reusable dry cleaning bags. So I hope you saw that in the chat, and that will also be shared with everybody in the email. All right. Well, thank you so much, everybody. Have a good evening. And thank you, Dr. Han, and we'll talk later.
Yep. Thank you. Have a good night, everyone.